Hello and welcome. Good evening if you're in Europe. Good morning out there in California and those of you out on the West Coast. And I think we've even got some people up in the middle of the night to tune into this. So hello and thank you for joining us. So I'm Mary Ryan. I'm the Vice Dean for Research for Engineering here at Imperial College. And I'm also leading the Transition to Zero Pollution, our sustainability strategy that's drawing together researchers from across the college to try and deliver a better future, a sustainable future. And I'm extraordinarily privileged to be able to spend the next hour talking with Peter, one of our alumnus. So this is the fifth of our Alumni Spotlight event, where we try to shine a light, I guess, on the passion, the expertise, and the brilliance of some of our amazing alumni. So Peter graduated, if you can believe this, way back in 1979 from mechanical engineering, and has gone on to have really quite a remarkable career that I'm really looking forward to hearing more about over the next hour. Okay, we're also very lucky this evening to have the president of Imperial College, Professor Alice Gast, here joining us. I'm just going to hand over to Alice for a few minutes to give some words of welcome. Alice.
Thank you very much, Mary, and thank you, Peter. And I'm really delighted to welcome such a wonderful group of alumni, students, and friends from all over the world. It's fabulous to see in the chat messages coming in from around the world. And our alumni and our students and our friends are our greatest advocates, and they're our ambassadors and our supporters. And I'm really pleased that you're here today to hear more about what's going on at Imperial and what's going on with our alumni. And this is going to be a fabulous conversation. I do want to take a moment to thank Nicola Pogson and her team that she has built in alumni relations. Our alumni and friends events are very much supported by our alumni office, and thanks to Anya and her team who are expert at running these events. As you well know, our mission at Imperial is to achieve enduring excellence in research, teaching, and innovation for the benefit of society. And as such, we are at the forefront of research and teaching addressing some of the world's biggest challenges, and the challenges abound. It seems every day we read dire predictions about the pandemic, about climate change, about cybersecurity, mental health, the future of jobs, privacy, higher education. And Imperial has been rising to these challenges, and you're likely aware of our many research accomplishments over this past year, and it merits saying a few moments about the work on the pandemic, because it really brought our campus together. It showed how when you do fundamental research and first-rate education, you can turn very quickly into dealing with something that is truly a global emergency. We have people working on new detection capabilities, new vaccine therapies, new therapies in the hospital, human challenge studies. And of course, many people are aware of our groundbreaking leadership and role in modeling the pandemic in our School of Public Health. You may also be aware that we've come together to have probably the most comprehensive study in the world, the REACT study. And the REACT study has looked at more than 2.5 million people across the country, across the UK, to track the spread of the pandemic, to understand this virus, and to make a difference in dealing with it. I've just learned from another event that the REACT study will be carrying on to look at long COVID. So that's really helpful for us. But another challenge we're addressing at Imperial is climate change and pollution. And of course, the scale of the challenge is huge. Pollution caused by people can be found almost everywhere we look. And we have a focus across the college, from medicine to science to engineering and to business. We happen to have the world's air pollution expert who measures pollutants across London in one of the most well-studied and understood urban environments. And you can look up the air pollution in London and then think about the health consequences from that, and think about policies that'll make a difference. So as Mary said, she leads our Transition to Zero Pollution initiative, and it's a transformative cross-disciplinary program bringing research, education, and innovation together across the college with experts in technology, engineering, policy, economics, and engagement to work together to realize a sustainable zero pollution future by addressing the entire system and the complexities therein. So for me, one of our most important measures of impact in all that we do are the great accomplishments of our students and alumni. The things they go on to do with their Imperial education are a testament to the research, teaching, and innovation we do on campus. Peter Rawlinson's passion and hugely successful work to address climate change through technology and engineering is inspiring indeed. This is going to be a fabulous discussion with Mary Ryan providing the great leadership in our transition to zero pollution effort, and Peter Rawlinson, who is ushering in that transition. So I want to thank you, Peter, for joining us today. You're doing important work, and we're all very proud of your achievements, and thank Mary for her leadership as well.
Thank you, Alice. So, Peter, welcome, and thanks again for joining us. So I know we could spend the whole hour just talking about your career, but I wonder if you could give us a whistle-stop tour of what you've been doing since you left Imperial College.
Oh, goodness. I left Imperial just as I was getting interested in cars. I wanted to be someone who designed things and made things and created things. And so I became a design engineer and designing cars. Not the styling design, the technical design of cars. I worked in the UK motor industry for many years. I was at Jaguar Cars, and I was very fortunate there that really got exposed to creating cars with a digital, within the digital domain. And we, long before there was an internet, we created internally an intranet where we could share files and CAD data and CAE data at Jaguar. And this gave me a real insight into the future of digital engineering. With that knowledge, armed with that, I went to Lotus. I became chief engineer at Lotus Cars. And after that, consulted internationally on vehicle engineering, particularly advanced material applications. And then in early 2009, I got a call from Tesla, who were looking for a chief engineer to lead the design of Tesla Model S. And I moved to California and led that program. Thereafter, I took a little sabbatical in the UK before coming out west again to join a little company called Ativa, which was a battery tech company, but had big ambitions to do an electric car. And I joined that company. We rebranded as Lucid, and we're about to go public on NASDAQ next month and launch our car, the Lucid Air, which you see behind me. This is not a green screen. I'm actually in our Los Angeles studio with a real Lucid Air behind me. And we're going to get this into production later this year.
And we noticed just before we became live that we all thought you had a green screen like the rest of us. I'm not actually really in South Kensington, unfortunately, but you really are in Los Angeles in the showroom.
I really am.
So,
yeah.
So you talked a little bit about your passion for design, but you came to Imperial to do mechanical engineering. So how did you end up going to Imperial College? What were your motivations?
Well, it's very interesting because I was brought up in South Wales, and I went for a day trip to Cardiff University, and I met the professor there of mechanical engineering, and he said, "You seem like a bright young chap. Why aren't you going to Imperial?" I said, "Well, where's that?" He said, "Well, I went to Imperial." And it was done in a millisecond. It's like, oh, well, that's the place to go then, right? So I went home and I told my mum, "I'm going to Imperial." She said, "Where's that?" I said, "It's London." Right, done. It was done and dusted in a millisecond.
So a chance meeting with one of our alumni, turns
Indeed,
out.
just shows how influential they can be.
So, and then you've recently come back to campus. I know you haven't been back for a long time. And what did you notice that was very different? And how did it feel coming back after so many years? And how has the place changed?
It was amazing, actually. And Professor Mike Lowe was such a gracious host, as was Shona Aiken. And you know, just meeting so many of the research students and fellows there, and seeing all the activity and the expansion, particularly of the mechanical engineering department. It looks so invested in. It was a fairly dreary old place in the 1970s, I can say, and it looked very vibrant. There was a lot of energy and a lot of brilliance and a lot of research, which really fascinated me in its relevance to the huge challenge that mankind faces today, which is the environment. And I was really buoyed by seeing so much relevance in terms of the research activities in that particular field.
Yeah, that's interesting. And we're going to come back to the environmental crisis in a little while, so hold that thought for a little bit. I guess just in terms of your degree at Imperial and then moving into industry, what do you think? I guess there's kind of two parts to where I want this bit of the conversation to go. One is what you learned that you took that helped you in your career, and how much you think the needs are now very different for somebody studying today. So what did you take from your degree that's helped you?
Well, I took mechanical engineering because I didn't really know what I wanted to do. That's a horrible.
I think many
reason,
of us
but
are guilty
it's
of
the
that.
truth. And I found that doing a course in mech eng would equip me with the fundamentals which I could deploy to what eventually would become my passion, which was designing cars. But I wasn't in love with cars when I actually joined Imperial. I considered marine architecture or aero engineering or something like that. And so I think what this did was equip me with a deep understanding of the fundamentals of the laws of physics and the application of the laws of physics. And and that served me throughout my entire career. And it's very interesting because I've really surrounded myself with brilliant people and done that in the various organizations that I've built up, from Lotus, Tesla, and here at Lucid. And, you know, until very recently, I would interview engineering candidates, and I would often ask them very technical questions at interview, almost like a mini exam. And it was always go back to the basics. What is your core understanding of the absolutely basics of maths and physics and the application of those in engineering? And I just think that we should never forget that.
Okay. Do you think so? I know we're an education institution and we're often being told that the needs of industry are changing. So I fully 100% agree. You've got to keep the fundamental depth of knowledge. Are there other things that students should now have that's just embedded? You know, when I graduated, everybody didn't have to understand, data-centric engineering. Everybody didn't need to be able to do, the software stuff. Are there some really fundamental things that we absolutely need now, as well as the basic principles? No, or do you think you just need a brilliant mind?
I just think a brilliant mind goes a long way. I've always prized intellect over experience. Not that experience isn't valuable. It goes without saying, expertise in the digital world, in simulation techniques and modeling techniques is virtually a given now. But, as a general observation, what I've seen throughout industry is there are not enough people who've got general knowledge and broad knowledge. My experience, particularly of the motor, I can only really speak of the motor industry, but it's, as a generalization, there are too many people with too blinkered a knowledge, a very siloed capability. And I'm pretty rare that I've got a breadth of knowledge right across a complete vehicle. And that's what's actually propelled me to the sort of positions that I've held. It's been the breadth of knowledge rather than the depth in a specific field.
That's interesting. And I guess that is one thing that we try to talk about. How do you bridge those interdisciplinary gaps? And it's somewhat easier to do at postgraduate level than undergraduate level because there's already so much to learn. But it's definitely something at a strategic level we think is critical. So I'm going to come back to the environment crisis. And one of the things actually in training we're trying to embed is, I guess, a sense of responsibility to the planet when you're doing engineering and delivering research. So what's motivating you now? You're clearly in a position to make a difference. What's driving you, and how do you see the environmental crisis being resolved?
So I think man has to move to a more sustainable lifestyle. And a big part of that, and not one of us can address all of this. This is a multidimensional, complex jigsaw puzzle, and it's a team sport. Each of us can just do our part. And I started off doing vehicle design just because it was a fun thing to do. It was really just it was like a sort of childish, immature dream. I was going to get paid to do my hobby rather than have to do down days work in my life. And I almost pulled it off until recently, when I realized I was thrust into this crazy situation where I realized actually, and I was not a great proponent of electric cars until very, well, 10 years ago. And it really dawned upon me. I saw electric cars as rather heavy, carrying a lot of batteries around. I thought perhaps a lean burn gasoline petrol engine might be more efficient, a lightweight solution, less impactful upon the planet's environment. And then I realized that actually, if we could make an efficient electric car, and that if that energy was generated in a sustainable manner, this would have a huge impact. And I can actually be in a position where I could personally influence and impact the world and make it better for this generation and for future generations through trying to accelerate mankind's transition to sustainable mobility and through electric cars. And so, you know, this sort of boyhood dream of designing fun things and designing cars has now been replaced by a real sense of mission in my life and the whole team at Lucid, that we need to accelerate the adoption of electric cars. Now, that doesn't necessarily mean a good thing, because I mean, there are some weird cases where electric cars are worse for the environment than petrol cars. I mean, in Hong Kong, there's a lot of Teslas driving around, but the way the energy is generated is terrible. There's this horrible old power station spewing carbon dioxide the other side of the island, and all the cars are being charged from that. It's probably better for the environment if they were all petrol powered. Yeah. But the reality is that with electric cars, we have the opportunity to generate that energy sustainably. And so none of us can solve all of these problems. The problems are just too big, but I can play my part in making better electric cars. And that realization dawned on me about 10 years ago, and it's really propelled me with a spring in my stride for the last decade.
So one of the big challenges in delivering this transition, of course, is giving people access, so equity of the transition and how you make technology affordable. And of course, many of these electric vehicles are, you know, quite inaccessible. So people can't afford to make those kind of choices. How do you see the industry, I guess, developing to enable? Is it a different model? Is it cheaper vehicles? Is it behavior change? Or is it all of those? And how is Lucid going to play its part?
It's all of those, and it's so complex, because if you look at the car behind me, and this is not a green screen, this is actually our Los Angeles studio. We're starting off with a car, the Dream Edition, which is wait for it, it's $169,000. So you think, well, how is that helping the planet, Peter? Are you mad? This is a rich man's toy. What's the benefit of that? The reality is we have to exist in a commercial environment. What I want to do is create a $25,000 electric car. That would take zillions of money, because really the price point of a car is almost inversely proportional to the sum required to industrialize it. So we have to start with a high-end car, and we're going to gradually bring that price point down. We'll get the car down from $169,000 to $69,000 within about 18 months. That's the plan of start of production. And then we want to introduce more affordable models. But there's a bigger picture chess game going on here, Mary. What we're doing is designing for mass production in the technology which is created in-house for this car. And that design for mass manufacture, design for process, will have a dramatic effect on pushing the price down of electric cars, because there are two big hurdles we need to address in terms of widespread adoption. One is range anxiety. Well, the car behind me has got over 500 miles range. So that addresses that issue. The other hurdle, which is the more significant of the two, is the price point of entry of that electric car. And in order to do that, we need to mass industrialize the technology. We need to advance the efficiency of the vehicle so we can get more miles per kilowatt hour. And that efficiency will be a big cost driver.
And you just talked about range anxiety, and of course there is also a big infrastructure challenge with the charging network, which, in terms of the car technology or the infrastructure charging network, which is going to be the rate limiting, do you think, in adoption?
I think they need to come hand in glove. I mean, there's an interesting historical precedent here Mary, that you know, when the petrol car came across exploded into the Western world about 120 years ago, the infrastructure was stables and ostlers, because it was most people were still using horses as their primary mode of transport. And they took the car first, and then the infrastructure followed. There were more cars than there were petrol stations. And I think there's something healthy about that, rather than forcing some sort of artificial construct into a free market economy. I think the electric car has to lead and the charging infrastructure follow. I think that's the healthy way around. But what I think is really important is that this may need a little bit of government assistance, because a lot of people can't access overnight charging if they're if they park their car on streets, if they haven't got garages. And I think there's perhaps a sort of myopia over focus upon fast charging on supercharging networks. I think that support at governmental level for on-street overnight slow charging would really act as a great catalyst here.
Do you see that as a likely reality? I mean, is that kind of policy initiative likely to move? Are there any other words from that, or any of the governments that you're interacting with?
Well, right now, China's leading the way. Europe's probably second. US is behind, but the Biden administration is really trying to push for a big initiative. There was an announcement just in the last 7 days. I think everyone's trying to move in the right direction. I mean, look, you're asking the wrong person. I'm an engineer, not a policymaker. But I just think what we need is the stars to align on multiple levels. We need to get batteries mass industrialized, so we get an economy of scale, so we can get beneath $100 per kilowatt hour. That's one thing, maybe to $90 per kilowatt hour. We need to really focus upon the efficiency of an electric car. Lucid Air behind me can get 4.5 miles per kilowatt hour in range, in efficiency. 4.5 miles per kilowatt hour. Now, that's a big car, a luxury car. We think that in about 2 or 3 years' time, with our technology roadmap, we could get to about 4.7, 4.8 miles per kilowatt hour. And if we applied that to a family car, more like a Volkswagen Golf type of vehicle, we might be able to get 6 miles per kilowatt hour. Now, if we can then link that with a maturity of infrastructure, if we knew there were fast charging stations on every street corner, that would serve as the antidote to range anxiety. Right now, with Lucid Air, we're carrying 500 miles of range on the car. We're actually carrying that range anxiety antidote in the battery pack of the car in terms of the range it carries. And I think that the electric cars of the future are going to have less range, not more, paradoxically. Because if we had that maturity of infrastructure and we knew we could fast charge anywhere, why would I need more than 150 miles of range? Then if I got 6 miles per kilowatt hour, the 150 miles divided by 6, that's only 25 kilowatt hour pack I'd need. Supposing I could make that at a cell cost of $90 per kilowatt hour. I could then make the cells for the pack would be $2,250. Maybe at pack level, I could get a pack for about $2,800, and maybe it would only weigh about 125 kilos. That's the way we're going to really crack this. There's no one thing. It's the technology, it's the industrialization, and the policy of infrastructure. All these stars aligning, and that will lead to a $25,000. Excuse the US nomenclature. I've been out of the pond too long. I should say about £20,000, shouldn't I? That's what's going to lead to the mass market car.
Okay, that's great. So we have lots of questions already in the Q&A. So I'm going to jump to those, and I just want to do some expectation management because there are so many questions. We're probably going to get through them all today, but we'll do our best to manage some of them. So I did one that I guess how do you see the balance between hydrogen and battery technology for cars? Do you think hydrogen is a credible alternative? I
think hydrogen is a complete technological dead end, and it's a no-hoper. I won't beat around the bush. I think it's just an absolute fantasy. But I do think hydrogen has its place for special applications, such as military, and aircraft. So it's a nuanced view, but for mass mobility, hydrogen is a technologically dead end, I think.
Okay, I think that's a alarmingly frank answer, but yes, I think that's interesting. So I guess a similarly controversial question, what would you say to someone who says we should just ban cars, that we should just entirely rethink mobility, and instead of replacing petrol cars with electric vehicles?
Well, I mean, there is an innate value in the quality of one's life, of moving around the planet and enjoying things and interacting and creating. So I think that we could take a very radical view of the world, and we could go back to the Stone Age. That would solve all emissions, wouldn't it? Why don't we go back to the Stone Age?
Okay, so question from Billy, who's one of our battery researchers. What have you found to be the greatest barriers to introducing new technologies, and what are your perspective on how we can accelerate the low carbon transition?
Biggest barriers for new technologies. I mean, the biggest barrier I found to creating the new technologies is getting money. That's been the biggest challenge for Lucid and as a startup. That's been my big challenge, is getting the money and getting the investment to create that tech. I think the biggest barriers to the adoption of that tech in the marketplace is range anxiety. And it's this perception of, well, I need a car the odd day that I'm going to do 500 miles. Well, how often do you do that? You know, I mean, I think we have to address range anxiety, but it's got a disproportionately weighted influence upon people's purchasing choice. That's what I think. Yeah,
I think that's right. So thinking a little bit more about the batteries, what are your plans to manage the supply of critical components and raw materials? So, you know, we've been thinking a lot about, you know, supply of lithium, supply of cobalt into battery packs.
Yeah.
But
I mean,
how are you managing that? I mean, and that in itself has a kind of an offshoring environmental issue. How do you wrap all of that into, I guess, Lucid's plans and as an environmentally green company, and the coupled, of course, social and geopolitical issues with critical material supply?
Yeah. I mean, there's tons of lithium, and it's not, I mean, it's a lot more nickel in the cells than the lithium, actually. They're called lithium, but cobalt is the enemy. And we've gone from a 532 NMC to an 811, so half the cobalt content. But, you know, it is a worrisome the way, you know, also the human conditions by which cobalt is extracted in the Congo. And we need to address that. Now, a little company like Lucid, if I tried to solve all the world's problems, we wouldn't succeed. Right now, we're focused upon making the best electric car in the world and making the best technology that this can attract a wider spread adoption and really accelerate this transition that's necessary.
I'm not going to quite lay you off the cobalt hook there, Peter. I'm not expecting Lucid to fix this by themselves, but you're right, it is a huge challenge. And it's a global problem, right? What do you think governments need to do, and what can organizations like, maybe not Lucid, but Lucid and BMW and Tesla and an organization like Imperial College, how do we have influence in those questions that make governments fix some of these problems? Because this is a geopolitical question, right?
It is a geopolitical question. It's really tough on this. I mean, what we can do is try to have that dialogue with the decision makers to show the electric car is real. It's going to explode in terms of its uptake in the next decade. And these are real issues which are not going to go away. It's a real tough one.
Yeah, I don't think any of us have the answer, but I think dialogue is important, and probably getting as many voices that have influence together.
But you're right, Mary. Cobalt's the issue. That's the big one that worries me the most.
Okay. And somebody asked what chemistry you're using, but you've just told us 811, so I think we can.
And NMC 811. Yeah.
Okay.
With 21700 format.
Okay. So there are lots of questions, I guess, relating to your time at Tesla, and I'm going to start with hopefully an easy one. What's the key advantage of the Lucid car electric vehicle over other possible examples, like maybe the Tesla or other electric cars that are available?
Yeah. Well, as you can see, it's a lot cooler. No, it's I don't know where to start actually. I mean, we want to take electric car to the next level. So all the technology is developed in-house. We've got the lowest drag force, lowest CDA of any car that I'm aware of. Until the Mercedes-Benz EQS came out with a even lower drag coefficient, we have the lowest drag coefficient of any car that I'm aware of. We've got the most efficiency. We're over 4.5 miles per kilowatt hour. Electrical architecture, it runs at 924 volts. Tesla runs at 400 volts. So you get less I squared R heating losses. And then we've got motors which spin to 20,000 RPM, and they do that without carbon sleeve. We have the most efficient drive units that I'm aware of. We bench tested those against Tesla, and we're getting 15% more efficiency in our drive unit technology than Tesla. We've got, in terms of power to weight ratio of the drive units, we're getting about 9 horsepower per kilogram. And Tesla is typically, I think, until Plaid came out, they were about 3.1, 3.2. So nearly triple the power to weight ratio. And because we've miniaturized the powertrain that way, we're able to bring the whole thing together where the whole is greater than the sum of the parts into something I call the space concept. And this is like for followers of Doctor Who. And in the US, most people don't know who Doctor Who is, but in this Imperial context, I can
Everybody here
relax
knows
and
that.
reference Doctor Who. So you know the TARDIS. The TARDIS is it's bigger on the inside and it's smaller on the outside. And we haven't quite got a TARDIS, but we've got the closest thing a car can get to it, because we've got a car which is more compact on the outside. In plan view, it's smaller than a Porsche Taycan, and yet it's got the interior space of a long wheelbase S-Class Mercedes. No one's ever done that, and that's due to the miniaturization of the electric powertrain. Tesla's never done that. Mercedes has never done that. So there's a whole bunch of things. Seeing is believing. When you get a chance,
Okay,
take a look for yourself.
so John has asked a question about heat management in battery systems, and I know that's something you've been thinking about. I don't know if you can share any of the benefits that you've brought into Lucid for heat management, and that being a limitation on battery storage.
Well, I can. I mean, the critical case for heat management is when you're charging the car rather than actually driving it. And and there's a little bit of a clue here, because we can get 300 miles charge in 20 minutes. So if I can get 300 miles in 20 minutes, you think that's charging at a rate of 900 miles an hour, right? Now, I can't drive the car at 900. It might be able to do 200 miles an hour, but I can't drive it at 900 miles an hour. That's faster than the speed of sound. So that is the limiting case for the thermal management. So what we do is we have end cooling for our cells rather than side cooling, which is Tesla's philosophy. And the cylindrical cells, it means the heat has to travel a little bit further along the axis of the cell, but the cells' thermal properties are very anisotropic. They conduct heat along their axis, their central axis, very much more than their conductivity radially or circumferentially. So we can leverage this anisotropic behavior, thermal behavior of the cells to extract heat in a much more practical way and a more efficient way than trying to side cool. That's just one example. And we've tried this with our Formula E racing, where Lucid makes all the battery packs for the World Championship electric motorsport series, the single-seater World Championship. All those packs in 24 cars are all designed and engineered and actually manufactured at our headquarters in Silicon Valley here in California.
Okay. So this is the question I'm sure you're expecting. So Max has asked, and many people have upvoted, how did you find working with Elon Musk, and why did you decide to pursue Lucid instead of staying at Tesla? But I think you left Tesla and then you had a break and then you joined Lucid, right?
I did. Yeah. So it was an amazing opportunity in life. Elon wasn't very famous then, although he had a fledgling rocket company at the time. He called me, and I was in my farmhouse in England, and he sort of interviewed me and said, let's have dinner again tomorrow in Santa Monica. And I was busy, and we actually, 2 days later, we had dinner, and he told me about this new car he wanted to do, which was the Tesla Model S. And And 2 or 3 weeks later, I was at Tesla. I was chief engineer on Model S. And it was a fascinating experience. He's a very committed man. I don't think he pushed me at all. I pushed myself. I realized this was my big opportunity in life, and I worked like crazy. It was me who pushed myself 200 hours a week, not my boss. But I mean, it was a great learning experience, and we created something very special in Model S, and I was there for 3 years. In the end, I came back to the UK. My mom wasn't very well, and so I went from flying around in Elon's jet with him to cooking the dinner and washing the dishes.
Okay, so I guess there's another question. Other car companies are also available, but there's a question here about Dyson, and Dyson, you know, talked quite a lot about creating an electric vehicle not so long ago, and it seems to have gone very quiet. Do you have any insights into what happened there? Well,
yeah. I mean, James Dyson, a great guy, and he had a great vision for electric car. And I know he's a great proponent of Imperial College, and I applaud him for that. And I've got to meet him on a couple of occasions, so we kind of know each other. And I think what he's doing is really amazing. He hit a brick wall with his Dyson electric car project and decided not to proceed with it. He didn't see it as a potentially profitable commercial venture. Certainly, that's what was publicly disclosed, and that was, when was that? About 18 months ago. I might have got the timing. Time flies. It might have been 2 years ago. But let me tell you, Lucid is eminently profitable. Electric cars are very profitable. They've got less parts than petrol cars. Don't believe that an electric car is not profitable. The profit margin is great. Tesla's inherently a profitable company. What it's chosen to do is adopt a business model where that money is plowed back in, because Elon's got a long-term vision for the company. He's thinking in terms of 15, 20 years plan. And that's what the sort of timescale I think in as well. So, you know, if you want to pander to market forces and show a profit fast, well, you can do that, but the real value is long-term. I'm disappointed that the Dyson car got no further. And I'm also disappointed that I can't do this in the UK. I wish I could do what I do. Why have I got to come to California to do this stuff, this crazy stuff? I don't know.
Well, we do have a question in the Q&A about your production plans in Europe and whether they're on track.
All right. Okay. So we built the first factory, purpose-built factory for electric cars in North America, in Arizona, near Phoenix, and cars are being built there as I speak. I'm off to the factory in a few days' time to look at the first of our production cars, which are rolling off the line. We've finished our pre-production run now. So that will serve the US market primarily, a home market for the next year. Then we'll enter the European and Middle Eastern market next year, and then probably likely to have a plant in that region. And then we'll hit China the year after, and certainly mid-decade, I plan to have a big plant in China, probably making our second platform.
Okay, so quite a few people are interested in autonomous vehicles, and we heard a lot about autonomous vehicles a few years ago, and then it kind of went quiet. And what do you see the future of a car being? Kind of a computer on wheels, and with maybe electric vehicles, or do you ever see that aligning with Lucid, or do you think that's not really on the horizon?
Oh yeah, so don't get me started. So it's already a computer on wheels. We've got an Ethernet linked gigabit highway connecting 60 computers in the car behind me. It is a computer on wheels. I mean, even the headlamps. I've got steered light beams digitally switched with no moving parts. This solid state digitally steering, even our headlamps, which is developed 100% in-house. If you look at our battery management system, we have 44 microcomputers linked to a central computer in the battery itself. So it already is a computer on wheels, and it's getting more and more so.
How close is it to being autonomous then?
So yeah, so here, this is the thing. I'm really bullish about electric cars, and I'm surprisingly bearish about autonomous. Autonomous cars are not going to happen anytime soon. That's my view. But it is a case of when it'll happen, not if. Surely they will happen, but we're not going to get robo-taxis in the millions anytime soon. The best estimates are to get to level 4 level of autonomy. It's about 10 years away and about $10 billion just for the software, 10 billion. And I was talking to an executive of a very well-known company very recently. He said, Peter, he said, you're wrong. It's a lot more than 10 billion, believe me.
Okay. All right. So question from Frank Kelly, who's I think the world-leading expert Alice was referring to earlier about air pollution in London. So nice that you're joining us, Frank. And he's asking about emissions, pollution emissions. Of course, tailpipe emissions will disappear, hopefully, at the point of use, assuming and globally, if you're assuming using renewable electricity. But what about things like wear emissions from tires, potential microplastics, which could potentially be worse with electric vehicles if they are heavier, higher torque. You might end up with more tire pollution than you would have in a petrol car. So do you have, is that part of the vision, and how do you think that should be dealt with?
Well, I think that's a very interesting area of research. I mean, if we were a bigger company, we could look at all those things. Right now, we've got a great partnership with Pirelli. I think in the future, we might be in a position where that could be a line of research. I mean, this is where efficiency is really important, because you're right, electric cars are heavier, so there will be more tire wear. And this is a very valid comment, but the more efficient we can make electric cars, the smaller the battery packs can be. Right now we've got battery packs in vehicles like this are about 550, 600 kilos. They're over half a ton. My model for the electric car of the future, that 20,000 pound car, could be a battery pack which is like 125 kilos. And then we start getting closer to the weight of a petrol engine equivalent in that paradigm. So I mean, Lucid's just too small a company to do research in all these areas, but I can see as we advance and mature that this would be a very interesting area to pursue. Maybe we could do it with Imperial College.
Yeah, well, actually, you could do it with Imperial College, and we can talk about that later.
All right.
There's quite a lot of there is quite a lot of work already going on in that space. I'll send you some information.
Thank you.
Okay, so there's an interesting question from Chris about the potential to use electric cars to stabilize the grid, basically. So using the fact that you've got this enormous battery network, effectively, once you've got electric cars. How do you see that building in? And I guess there's a policy and a finance and an infrastructure needed for that. But is that part of, you think, of the future vision?
Absolutely. So I'm from Wales, and in North Wales there is Dinorwig Power Station, and this is where there is a lake on the hill, and it exchanges electrical energy for potential energy to help balance the UK grid. So instead of having a lake on the hill, why don't we access the electrical energy stored in the battery packs of cars? So Lucids will have two-way charging from the get-go. We have this Wonderbox technology, Wonderbox silicon carbide switching technology, and we've got 19.2 kilowatts standard of vehicle to grid capability in the car behind me. And this is real, and it's going into production very soon. Actually, the cars are being produced now. And then I believe that with big data is a big part of this, that we can help balance the grid. And it's very interesting that effectively we will have little stores of that old Dinorwig Lake distributed all around the grid. It can make the grid more robust and less prone to failure. But there are three tiers of usefulness of V2G capability. One is lifestyle. You can power your home if you're, if you've got a power cut. You can actually power a holiday property that may be off the grid. Maybe you've got somewhere in the Scottish Isles, and you can power from the car. The second level is at a business level. Here in the US, we have this. We pay for our electricity based upon not just the overall units of energy use consumed in a year, but through the peak power ratings, the peak surges of power drawn from the grid at peak times of the day or the week. And so what we're going to do at Lucid, once we've got the car in production, we're going to offer Lucid Air owners free charging outside in the car park, and the quid pro quo will be that the energy will come from the cars, the power, the requirements of the building will come from the cars operating in a V2G mode, and that will be peak shaving, that we will shave the peak power draw from the grid. And then, of course, the ultimate level is for nation states really balancing the grid. This is a big part of our plan, and I'm really optimistic about it. I think it's very exciting.
Okay, so good. So there's kind of a few questions about geography. So there's a question from Robert, Clayton, and Leo, and Billy. So I guess why is Silicon Valley so successful in startups? Where do you think the competition between China and the rest of the world is going? And why can't we do this in the UK, Peter?
I don't, and so this is a crazy thing. This is me. So when I joined Lucid, it was called Ativa then, and I wasn't CEO then. I spoke to the founder and I said, look, if you want to do an electric car, let me tell you the best place to do it, in central England, because there is a culture of world-class engineering. And you're going to hate this, but the engineers have, the salaries are about 1/3 of Silicon Valley. It's about a 3-to-1 ratio. So I said, the very worst place to do this is Silicon Valley, because it costs an absolute fortune. It's a bit like saying, I'm going to set up a car company and a factory, and I know I'm going to set it up in Mayfair or Chelsea. How dumb would that be? That would be the worst thing you could imagine. You'd want to set that up in Coventry or the West Midlands or somewhere like Birmingham, wouldn't you? You wouldn't want to do it in Mayfair. But really, that's what's happening. And I think it's a reflection of the sort of finance community. There's this perception that you're more investable if you're in Silicon Valley. And I think this is of this era. I think we could break the mold. I think the UK could break the mold. What the UK needs is just to show brilliant technology, innovation and engineering. And surely the financing should be a world market, not something that's pro and the preserve of Silicon Valley.
So do you think, so just to touch a little bit more on the I guess the global aspect and competition with China in this space?
Oh yeah. So it's very interesting. I think that in terms of federal policy, government policy, China for EVs, China is the world leader, and then Europe, and then the US. Now the really strange thing is, if you actually look at the technology, US is dominant because Tesla is the preeminent force in EV tech. And Lucid's going to join that, and we're going to try to make it a 2-horse race. Well, we're going to make it a 2-horse race because right now it's unhealthy. It's a 1-horse race with Tesla, and the world needs healthy competition. Now, there's a lot said about, there's 10,000 electric car companies in China, but let me tell you, and I'm not being disparaging about Chinese at all. A lot of my friends are Chinese, and I've got brilliant Chinese engineers at Lucid, but the reality is, 99.9% of those car companies in China that are doing EVs or having a crack at them are very, very low tech. There's only 1 or 2 that are really having a decent stab at it. There's XPeng and there's NIO. I know William Li doing a great job, but they're no Tesla. Tesla's just years ahead of all of these in terms of its tech.
Okay. So I have a question from Will, and I guess this is the last battery question I'm going to ask you. We've got a lot of interest in the battery technology. Where's the next important step in EV technology, and when will it be deployed commercially?
What's the next step in EV technology? The next big step is going to show the efficiencies of the whole powertrain rather than a myopia on batteries. But within batteries, I'd like to see the value of lower internal resistance. If we could go, some of the cells we're looking at, 21,700s, 25 milliohms, if we could get that down to 10 milliohms, that could have a profound impact upon efficiency through reducing I²R losses. I think that solid state has flattered to deceive for so long. I'm not expecting it anytime soon. It may never happen.
Okay, thanks. So do you want to comment on going public?
So yeah. So
the company, I mean.
We hope we're going public. We've got shareholder meeting this week, extraordinary shareholder meeting. We're merging with Churchill Capital. They're having a shareholder meeting on July 22nd. Fingers crossed, and subject to all that going well, the merger will be completed on July 23rd, just less than 4 weeks away. Hopefully we'll be ringing the bell on Wall Street and launching Lucid Motors as LCID on NASDAQ on Monday, 26th of July.
Okay, so, well, fingers crossed. You've talked a little bit about the challenges of getting investment and, you know, building a company. What is there one piece of advice you might give to other people who are, you know, at a much earlier stage? Absolutely.
I really believe there are 3 pillars for success, and you can apply this to so many facets of life. One is you've got to have the raw ability to do something. The second is you've got to have absolute commitment if you're going to make it real and bring it across the line. And third thing is you do need an element of luck. You need a fair wind in your sails. You know, you can have the best brains and be all in committed. If you've got sheer bad luck, you need the dice to roll for you. So it's that ability, commitment, and fortune that really collectively conspire to success. But I do think that the first 2 can help make the third factor happen in your favor. Sometimes we make our own luck in life, don't we?
We do indeed. So I know you've got a hard stop, Peter. So I'm going to wrap up with the last question. And just to note that we've got a lot of Imperial students online tonight. What message would you give to them just starting out in their career? What's the technology they should be interested in? What should they be striving and driving for going forwards? What would you tell 20-year-old Peter?
Gosh, I don't know. I mean, I did what I thought was going to be a fun night. I did what my heart told me to do. I wanted to go design cars, so I just thought I was going to have fun designing cars. So I just followed my heart. But who could ever predict that would lead to where I am now? You know, I thought all the fun had gone because I thought all the fun designing cars was in the 1920s when all the innovations were taking place, 100 years ago, and suddenly it's just a complete open chessboard again with where we can take the electric car. So I just think go where your heart takes you, and you know, maybe with a good dose of luck and a fair wind in your sails, you'll have an absolute blast.
Okay, I think that's a perfect piece of advice to end on. So I would just like to thank Peter for really being so generous with your time and your honesty and your inspirational answers to all the alumni that have joined us today and to our current students who've joined for this event. You will get a recording if you want to listen to it again. I'm sure. And apologies to all those people whose questions we didn't answer, but hopefully we covered, I guess, a lot of the topics. Thanks.
Thanks so much for inviting me. Thank you.